new or new and innovative companies. We are having Nicolas Salomaa from Nolla E, Tove Lindblad from Sweden, working for Trimble, and Sara Tikka, One Click LCA. Rather short lectures, and then we can have a discussion. And then after a short break, we continue with Kati Vierikko from Syke, from the State Environmental Research Institute. And we take a bit broader view to circularity and biodiversity in planning. My name is Panu Lehtovuori, and I will moderate today. As always, let's make it active discussion. Use chat and raise your hand in case you want to intervene, put in questions and comments. Raul, is there something technical we should remember to remind?
No, everything is okay. That also remind to our attendees that they can put the question in the chat. We will look at that, and also if they want in the discussion session to write their hands, so also they can be involved. No, that's all. I have started to recording the session in case someone want to switch off the camera.
Yes.
We have a question or a comment. Kati, please.
Yes, I want to make sure that I can share my presentation later on. At least at this moment I can't, so maybe you check that later. I have a possibility to share.
Okay, you should be able.
Yeah, now it's working. Thanks.
Okay, good. So everything is fine, and we can start. Panu.
Are we ready to start?
Yes, but it seems like Panu had some problem with the connection. He's not here. Panu, are you here?
Okay, I had a connection difficulty, but now it seems to work again. All good. Yes.
Okay, let's start then.
Yes. So for the speakers, if it's okay for you, we record these sessions, and we start with Nicolas Salomaa, then Tove Lindblad, Trimble, and then Sara Tikka. Maybe if you speakers are already with us, you can put cameras on, and we can make a brief round of presenting ourselves. Hello, warmly welcome to our event. Hey, good to see all of you. Yes. Do you want Nicolas? You can say a few words about about yourself and Nolla E. It's quite interesting company.
Oh, thank you. I'm a retired guy, actually. I'm in the process of doing a complete energy efficiency retrofit of my house. And I hope to get at least close to the Enefit standard, or maybe, well, Enefit will do. Yeah, that's me. And I've no background. Well, I've got a master's degree in architecture and the sustainable environment, but I'm not an architect. So that's me.
Okay, welcome. It's good we are having international audience as always in these sessions. Welcome. Yes, Nicolas, please.
Yeah, I'm Nicolas Salama. I'm the founder of the company Nolla E, and we are working making buildings carbon neutral in a way that is financially profitable. And we're doing this by using a software. I will tell you later more about this.
Great. Tove Lindblad, warm welcome.
Thank you so much. I'm Tove Lindblad. I'm located in Sweden. I work for Trimble with a main office in Sunny Valley in the US, but also we have a big office in Espoo outside of Helsinki. We do transforming in the way the world works. So that's what we do. We are an industrial technology company with solutions connect the physical and the digital worlds to help and solve complex industry challenges together. And today I will explain about how we can help a sustainable construction. Yes.
Great, welcome. Sara-Tikka, One Click LCA, promising name.
Yes, hopefully at least. Hi everybody, my name is Sarah and I work with One Click LCA as a project manager, and well, our aim is to try to decarbonize the whole construction sector by helping with some LCA calculations and preferably making them a bit more feasible to do for everybody. A bit more on the company whenever I start talking, but yeah, point is to go over some calculations and carbon footprint of buildings.
Okay, welcome. I think we'll find some answers to the questions. Is this carbon neutrality a possibility? Of course, we do think so, but it's not an easy target. And then we have Kati Vierikko. After break, we end today's session with Kati's lecture on circularity and biodiversity in planning. I think I saw
Thank
Kati
you.
too. Yes, so good to see you. Welcome.
Thank you, Panu, and thanks for inviting here. And yes, I'm a senior researcher at Finnish Environment Institute, and my speak is about how to achieve biodiversity neutral or positive urban environments, because nowadays this has been raised quite heavily also in Europe, that when we are aiming to carbon neutrality, we should also aim for biodiversity positive and neutrality in terms of not losing any more biodiversity.
Exactly. So we end with, as said, broadening and bringing more complexity. Of course, the systemic view to raised to industry is not simple either. But when we're looking the whole cultural and ecosystem together, there are quite complex questions in front of us. Hopefully, we are having good discussion today. And without more words, Nicolas Salama, floor is yours, please.
Thank you. And now, can everybody see this? Ah, sorry. Now you can probably better.
Yes.
Yes, now it works. Yes.
All right. So I'm Nicolas Salama from Nolla E, and I will first tell you a couple of words about the company and then talk about holistic energy solutions, which is what we are doing. The holistic energy solution is an opposite to a very the normal way of doing energy consulting, which is mostly sub-optimizing. Sub-optimizing means that there is one part, usually the part of the building that is the heating system, that is optimized for a building, and only the heating system is taken into account when a consultant is trying to find the best heating system for a specific building and maybe a cooling system. The holistic approach differs from this in a way that the focus is not on the specific units like heat pumps or solar panels or something like that, but the focus is on the building, a holistic view of the building, and the building is looking for the best solution, which is usually a combination of different things. But first, a couple of words about Nolla E. We are an energy efficiency consultant company, and our main focus is on financial outcome of different alternatives for energy efficiency measures. Because this does not mean that we don't save the world at the same time, but when we have the focus on the financial part of the energy, we usually get things done. And the projects where we are calculating very good return on investments, they are usually also performed in the way that is maximizing the savings in carbon emissions. And one central philosophy in how we do this when we have a holistic approach to energy efficiency of buildings is that we believe that there is always one perfect solution for every building. It is a different solution for every building, and it's always a combination. There is no heat pump or solar panel or any other project that in itself would be the financially best one or the best one from a perspective of carbon neutral buildings. But when we combine things, that's when we find optimal solutions that are both financially and for the environment the best solutions. This is what we work with. And holistic energy process starts always with a simulation, because in order to get a holistic view of the building, you have to start with a simulation of the building and understand the building. That's the first step. The next step is re-engineering of energy flows. This means that the energy flows of the building are optimized. And a combination of energy efficiency measures that together bring the biggest savings in both money and carbon emissions is found here. And what we get out of this process is the most profitable combination of energy efficiency measures. And that's the frame for design. And from there on, designers continue the work. The first step, simulation, means that in order to understand the building has to be modeled very carefully. Not only the windows and the doors and the walls and those things, but also ventilation ducts, ventilation units. We have to understand the temperatures inside the building. We have to also look at how the building is. If it's a retrofit case, we have to look at how the building is used. How many people are living there? How are they using? When are they using electricity, and stuff like that. And when we have got all this information, we draw the building into the software, and the software runs a whole year, 1 hour at a time, 8,640 hours, counts all energy processes of the building simultaneously, 1 hour at a time. And when we have done this, we know every kilowatt hour that the building consumes annually. We know when, where, and how much energy is consumed. This is the first step. For this, we don't need Nolla-E. This can be done with other softwares also. There are several simulation softwares on the market. And also you get the same results. All the different softwares pretty much they calculate the same way, so you get the same energy performance independent of which software you use, as long as you use real softwares made for this. But the second step is where it gets different. We call this re-engineering of energy flows, and this means that after calculating how the building is right now, or if it's a new building, how it would have been built without optimization. So the next step is that the software starts calculating 1 year again, 1 hour at a time, but it changes something in the building. And then when it's done, it starts all over again and calculates and changes something else. And it does this for several hundred times with all the different possibilities that the building has, from different insulations to different HVAC solutions and different heatings and ventilation units and everything that is possible to do with the building. And when it has done calculations for like 500 to 1,000 times with different products and different solutions on the building, then it starts combining the different products and solutions and calculates one more time for every different combination the 1 year at a time, the whole year. And when it's done, it shows the financially most profitable outcome. What is the cost of the investment? What is the return on investment? And also, of course, what is the impact on the carbon footprint of the building? Here is a peak heating load of a building where we performed a holistic energy retrofit 4 years ago here in Turku in Finland. Here the peak heating load, this is actually, it's the same building as on the previous slide. This previous slide shows the annual energy consumption, energy heat losses, where the heat losses are going. And this shows the moment when the outside ambient temperature is -26, which is the dimensioning temperature of southern Finland. And the case with this apartment building was that the peak heating load of the building was 288 kilowatts. And they had oil heating, and they had very big oil bills, and they had come to the conclusion that they have to do something about this. And the obvious fixes to this problem is to switch the heating system from oil to district heating or geothermal heating. And this apartment building, the people that live in the apartment building, they had got offers for switching to district heating, and also offers for switching to geothermal heating. And they decided that they want to switch to geothermal heating, and they already had they had the process started to making the purchasing. And when somebody in the building said that, hey, this 493,000 euros that we have to spend for this geothermal heating system, it's quite a lot of money, and none of us know anything about geothermal heating. So what about involving an expert in this project? And that's where we got involved. The end solution was geothermal heating, but combined with 19 other energy efficiency measures. And all these energy efficiency measures together, including geothermal heating, the final cost of everything was 467,000 euros, whereas only switching from oil to geothermal heating would have been 493,000 euros. And the thing why this is possible is that the other energy efficiency measures performed on this building lowered the peak heating load from previous 288 kilowatts to 100 kilowatts. And a geothermal heating system has the cost of a geothermal heating system is very much related to what the size of the system is. So by lowering the size of the heating system from 288 to 100 kilowatts, there was such a big change in the price of the heating system that we could do 19 other energy efficiency measures on the building that made the building more comfortable for living, and also, of course, lowered the heat losses and the heating demand to a fraction of what it was earlier. And why is this done like this? Is that if this apartment building would have continued heating with oil, the next 20 years would have costed 2.3 million euros. These costs are total cost, including not only energy, but also maintenance and service and wearage of equipment. And for cases where investments have to be made, always calculate the interest rate of what is the price of the money for the who is doing the investments. So they would have paid 2.3 million euros for 20 years. By switching to district heating, even if the cost of investment would have been 150,000 euros, they would have saved 500,000 euros. So that was okay. And for the geothermal heat pump system, they would have saved almost 1 million euros. So that's also quite an okay investment. But now, when we did this with a holistic approach to the building and optimized all the different energy efficiency measures for this building, we are now about 40% less in total cost for 20 years, which in this case means a little bit more than 600,000. And also, this meant a smaller initial investment. And if we look at carbon emissions of this building, the emissions would have gone down to approximately 40% by a geothermal heat pump system. But with this re-engineering of energy flows and all the 20 energy efficiency measures performed at the same time, the carbon emissions got lowered by 86%. So that's quite a lot, quite a big difference. If you have questions, just raise your hand, because then when we get to the end, you probably don't remember them anymore. That was a typical apartment building project made with holistic approach. Then there are, of course, many and very different kinds of projects. This case called Toriparkki is very well known in Finland. This is actually the biggest solar thermal seasonal heat storage in the world right now. This is the city market square of the city of Turku, where there was built a two-store parking lot house underneath the market square, and this does not sound very carbon efficient. But this on top of this parking house, they built market square like cafes and stuff, and around this parking house there is right now they're building a shopping center. And on top of on the surface of the market square, the city of Turku wanted that it will be kept ice and snow free in the winter, in order to avoid people getting hurt when it's slippery in the winter. This was the information provided 2018 when we started planning this project, and then there was one more important information, was that the city of Turku is built on clay ground, and right here where this parking house was built, there is 50 meters of clay underneath. So the parking house and all these buildings built here, they have to be built on piles, so that the constructional piles to keep the building from falling into the clay. This was the information we got, and here is what we did. The city of Turku is supposed to be carbon neutral by 2029. And since we only have about 8 years left, and it is really not carbon neutral right now, we have to do a lot of things different in order to reach this, because by doing the same things, you will only get the same results. In this case, we have done something really different from the way these things are usually performed. Here is how the market square looks right now. In order to have the market square surface ice-free in the winter, there is pipes underneath the surface stones. And in these pipes, warm water is circulated in the winter to get the ice, to melt the ice. In the summer, we use the same pipes to collecting solar heat. And in the summer, we don't need the heat, so we store it for next winter by using the 2,000 piles that these buildings are constructed on. We circulate solar heated 20 to 40 degrees Celsius water in the piles pretty much the whole summer. And this makes the clay around the piles get warmer and warmer, and in the end of the summer, the clay is so warm that next winter we can keep the market square surface ice-free. We can warm up the buildings on top of this parking house, and also warm up the shopping center around it. And of course, heat the parking house. And in a system like this, when the heating is done by solar, we don't use any other energy than the one needed to circulate the water in the pipes, circulation pumps. And circulation pumps, they consume around 0.5% of the energy circulated in the pipes. This is carbon neutral. So from initial design, with 10.6 gigawatt hours a year of heating energy needed, we have gone down to 0.1 gigawatt hours a year. And this is also a project that is financially profitable, otherwise it would have not been done. The cost of building this whole system was we calculated that it would be 6 million euros, and it was. However, we also applied for a energy, what's it called? Energy. The government is giving some grants for new types of energy systems in Finland, and I believe in other European Union countries also. And we got a grant of 1.3 million euros for this project. And also there are some investment costs that would have been performed if this system would not have been built. So in total, the added cost of this system is approximately 4 million euros. And the annual savings in energy costs are approximately 840,000 euros. So it's quite financially profitable, even if it lowers the energy consumption down to around 1%. So the energy saving was 99%. Other type of projects that we are involved in is this shopping center in a city called Rauma in Turku, in Finland. It's this shopping center is like a average shopping center in Finland. It has all the Swedish coffee houses and the Norwegian electronics shops and Swedish retail shops that shopping centers usually have. What is different with this shopping center is that this shopping center is carbon neutral. By using the holistic approach to this shopping center, we managed to drop the annual energy consumption of the shopping center to 1/3, from 4.8 gigawatt hours a year to 1.6 gigawatt hours a year. But this does not make it carbon neutral. What makes this shopping center carbon neutral is that there will be 5 apartment buildings built next to this shopping center, and these apartment buildings are heated by the waste heat of the shopping center. So when we take the annual energy consumption and also the annual carbon emissions of the shopping center, and we take off the how much this shopping center, the waste heat of the shopping center does decrease the heating energy, and carbon emissions of the apartment buildings, we are pretty much in zero. Of course, the building of this shopping center is not carbon neutral. But when we talk about carbon neutral, in this case, we talk about the emissions of the lifetime of it, the time that it is used, not the building, which is for shopping centers pretty much at least 65% of the total carbon footprint of the building. And also here, the most carbon neutral solution for this project of buildings was also the most profitable financially. The investment cost of the shopping center was the added investment cost was a little less than 600,000 euros. And the OPEX of the building when we have the apartment buildings in use, when they are ready and people live in them, we are saving about 400,000 euros a year. So that's quite financially profitable. And then we have also holistic energy projects performed in other countries. Here are 20 hotels that we did this consultancy in Doha in Qatar. 20 hotels, they were identical. And the total net surface of one hotel was 3,560 square meters. The peak cooling load of one of the hotels, one hotel is 117 kilowatts, which we decreased to 21 kilowatts by doing many different 20 different energy efficiency measures. And the purchased energy was decreased to 1/3 from the initial annual energy consumption. The cost, we got the cost lowered to around 50%, and the initial investment, the added investment was such that it was only 60,000 euros additional investment and 23,000 euros a year in savings. And all these are not savings in heating energy, but in cooling energy, since we have ambient temperature of 35 degrees Celsius almost the whole year. We have very humid outside air, and also very strong sunshine every day, the whole year. So the focus was on cooling. And the more projects we have performed in countries in the south, we have found that the buildings in warm countries use at least the same amount, and in some cases even more energy for cooling the buildings than buildings in the north use for heating the buildings. There's another project from a warm country, Maldives, an island with 60 villas that look like this. And also here, cooling was the main issue. The peak cooling load of one of these villas was 6.7 kilowatts. and by using 15 different energy efficiency measures, it was lowered to 1.2 kilowatts. And the costs of annual energy, since this was an island in the Maldives where all the electricity has to be produced on site, and the all electricity was produced by diesel generators. The electricity was quite expensive. So the holistic approach in this case cut the costs from 3,500 euros a year to 78 euros, which is pretty much okay. And the added investment cost of performing these energy efficiency measures was 3,300 euros. So we are talking about 1 year's energy cost, and the buildings have been transformed into carbon neutral buildings. One more case, and then we have to get to questions, because otherwise we will not have time enough. We have to stick to the schedule. A logistics terminal, an office building in Copenhagen in Denmark, where there was the same thing as usually, a lot of energy consumption, and I thought that maybe all this energy consumption is not, maybe there are some things to do to decrease the energy consumption, which are profitable. In this case, a logistics terminal that has some devices used for the logistics process that did make a lot of spare heat, and which especially in the summer is very not so comfortable, and also big cooling loads in the offices. But also the peak heating load was in the start quite high for a building being in Denmark, 738 kilowatts, which was decreased with energy efficiency measures to 512 kilowatts. The heating was, however, not in the main focus. The cooling was more important in this case, because the heating energy produced in the district heating system in many cities in Denmark is very close to carbon neutral. There are solar heating systems and such that produce the heating very close to carbon neutral, and also as renewable energy often is, after a while it is quite cheap actually. So in this project, the main focus was in the electricity consumption, and the changes in heating consumption were like side effects of reductions in electricity consumption. But the annual energy consumption was decreased by 30%. And again, the focus, of course, in a business building is always on the profitability. And in this case, an initial investment of 430,000 euros made it possible to save more than 100,000 euros a year, which is pretty okay. It does actually make the building carbon neutral however, not the logistics process that consumes a lot of electricity, like forklifts and these package handling units and stuff like that. We cannot decrease the electricity consumption of them, but the building is now carbon neutral. And now I see that the time is out, and there is questions. I will happily answer them.
Thank you, Nicholas. Very interesting and concrete examples. I was happy to hear that combining like this shopping mall plus housing, you need a bit larger scale sometimes to achieve best results. So from one building, in that case, we moved a bit to urban design scale. Yes, other questions from audience to Nicholas? I think it's very clear. We will hear in the next presentations more about the embedded energy, about the carbon footprint of building materials and building processes. You said very clearly that your work is for this use time energy consumption. So it's good to remember these different dimensions of energy and carbon. Would you say, I mean, based on your experience, that in new projects and in retrofits, it is possible to achieve more or less carbon neutrality?
Yes.
In most cases.
Yes, we do. We do all the time. Now since the definition of carbon neutral is actually, we have one definition for that. We can say that, and in 9 cases out of 10 we reach carbon neutrality. And also we have to always say that this is not performed with single energy efficiency measures, but it needs a series of energy efficiency measures always.
Yes. Good. I see Sampa having a question, please.
Hello.
Hello.
Thanks for Nicholas for the presentation, and I was just wondering about the other measurements or like actions besides changing the energy source. What kind of things do you have to do to accomplish this energy efficiency and carbon neutrality in this kind of projects? For example, this shopping center, is it just like better windows and deciding what spaces not to, what spaces to heat and what not to heat as much, or what all things is included in that?
Yeah, there is by only switching the heat source, it's not possible to reach carbon neutrality. It's you have to take into consideration all insulation materials, the materials and the amount of insulations in different surfaces of the building. And also there is the ventilation is very important in shopping centers and this kind of buildings with big airflows. And so for instance, in this case, we changed all the ventilation units to not in all cases the ventilation units, but some parts of the ventilation units. Ventilation units are boxes that include components from quite a few manufacturers around Europe and other countries, and the performance of the energy performance of a ventilation unit is always a sum of the components inside it in relation to the airflows and the temperatures and such. So that's one big part of it. And then of course we also we changed how things are interrelated to each other. There is, for instance, in this shopping center, there was more than 20 different energy efficiency measures. There was a lot, around 40 or something, to achieve this. But of course, that also includes then the apartment buildings, because we also made a holistic energy calculation on the apartment buildings, and also then finally on the shopping center and the apartment buildings, in order to find the optimal way to do this in a cost efficient way, and of course carbon efficient way.
Yes, good. Time is running. It's very interesting. Let's have a very brief question from Ian Brooks, and then we have to move on to the next presentation. But
thank you very much. Yes, thank you, Nicholas. Fantastic, really interesting projects. But I noticed that many of them have much higher capital costs. Does this mean that there are very few clients who are likely to accept your approach?
We get more and more clients all the time. We actually our company went up with, our turnover went up with 300% last year. So this is actually, I think this is the new trend for building investors and real estate. What do you call it? Real estate investors.
I'm glad that that's the case in Finland and clearly in the Maldives as well. I'm not so sure about the UK.
Yeah. Yes, I understand that at least in these cases Nicholas presented, the direct savings on energy costs are so big that they offset the higher capital cost in only in a few years. I guess that must be the main reason. Yes. But it is true, it's still an issue. I understand that.
Right, thank you very much.
Good. Thanks a lot. Very interesting material. Let's move on. Tove Lindblad and Trimble. And as said, I think we'll be hearing a bit more about the embedded dimension of energy in Tove's presentation.
Yes, I hope so. Let's see, to share my screen. Here we go. Do you see it?
Yes.
Great. So hi everyone. My name is Tove Lindblad and I work at Trimble. And today I will intend to give you knowledge in how building information models can actually contribute for sustainability. I know this is an event for architect students, so I would also like to mention that we do have the Trimble SketchUp, which I hope several of you already used in studies or in private. If not, please Google it and keep going. And today I will focus on our tool for designers, the technical structures and the benefits of using those constructible models for sustainability. I will just start with a very short brief who we are if you don't know us. Our mission and vision are to transforming the way the world works, and we do deliver products and services that connect the physical and the digital world. We are everywhere, I would say. Trimble started 1978 by Charlie Trimble and is grown today to over 11,000 employees worldwide. So in the northern of Europe, in Scandinavia, we're about 900 and about 200 developers. So we're pretty big. We also do the hardware. We have one of the factories just right outside of Stockholm doing total stations and scanners and so on. So you can find us there. And the third slide regarding what we do and what sectors we are in. So we operate in several different sectors with different technologies and solutions. I would say we're 50-50 software hardware, but we're aiming to be there for the industry and kind of link it to the location bound information. That's the key point. So the goal for today, what's my goal for you guys? I want you to understand why the building information model, we use BIM, and I will use BIM when I'm presenting this presentation, that will contribute for sustainability, as well as I want to show the value of an interrupted workflow of information throughout the whole life cycle, with emphasis on the climate impact, as well as I want to give you the benefits of the constructible models for sustainable construction. So these 3 bullets will be my main kind of goal for this session. So this is an ad from 2019, and it's about embedded carbon in building materials. So the effect of embodied coal in construction industry is an issue that has grown to greater concern, and now more often engineers are encouraged to assess and consider the building's carbon footprint for their projects. To show this, I would like to bring up the saying connected construction. That is digitalization, it's a process where we go. We are thinking of a flow from planning to design to construction and the management and the maintenance of buildings. The flow should sit together even if you work with a solution outside of our portfolio, the Trimble ecosystem. With the open platforms will be a key point so that we all in the industry can communicate and do this together. I mentioned BIM, and it's actually the I in BIM that is a so important piece in the puzzle of this. We think about the information and then how we should represent that information. If it's a table, drawing, text, 3D model, whatever, I mean, it's there, it's the information. And you must have full control over the data, and that the data is up to date. That will be important for you. And this goes to vertical and horizontal. And the vertical, I mean, that's buildings and structures. And I go horizontal, that's civil and infrastructure. So this picture kind of serves as a visual image on how we see the life cycle in both ways. And the life cycle where the constructible information with the help of the constructible models takes the projects forward. This is nothing new, in fact, but it reflects actually what we have in front of us with the future of sustainable work, with the climate work, with climate footprint and the climate impact. These 3 challenges, the communication, the information, and the change, they must work more seamlessly. And this is not a guess, but I think that we need to streamline and replace all the time-consuming tasks with an efficient way of working. So this image of the process, I've seen it the first time when I studied at studied early 90s at my 4-year technical college. Unfortunately, though, I saw it again not long ago, completely unchanged. But I know that there is an improved process. There is companies that actually has adopted this journey to work different, to work with the constructible models. And together we can use the models, we can gather all the information in all stages in the project. And the building information model will be the place where this information in each state can be stored, updated, and also available. I mean, you simply remove those dips, and consequently, the communication becomes more fluid. The data management is easier, and the change coordination will be faster and, of course, more efficient. And this benefits everyone involved in sustainable construction through digitalization can use. This picture, as you see, I've put BIM as hard in the middle, and the constructible models will help with this. Today, we already build without drawings. You use model views instead. You use mobile devices with those constructible models, because it's the level of detail, i.e. the degree of maturity of the model. If that's high, if that is exact, then that will help you. We must therefore be able to communicate between all those different tools. We need to communicate between different disciplines and over time in real time. And the importance of having the data up to date at the same time becomes very necessary, because we must therefore take the model and make that available. We need to make the data available. That becomes the object base in order to manage this together and in order to be able to work sustainable. Trimble has taken a very active role in this development of new standards and new formats. We believe in open BIM and open format. And what does that mean? I think the easiest way to tell that is to compare it with a non-open format, i.e. the company-owned format. That means that you will actually get stuck in a software. If you sit down and work in a non-format, you will be locked in to the model, and we don't want to be there. We want to communicate. We want the industry to do this together, and we must do this together to solve the common goal of sustainability. And here you can see a couple of examples of open formats, for example, IFC or GIS or OpenBIM or OGC, and so on. So for me, constructability or constructible is equal with sustainable. You need them both to do this. You need them for design. You need them for collaboration and BIM. For me, sustainable construction is, the carbon dioxide impact of the design, and we hear that already today, will be examined more and more. And it has probably not escaped from anyone that there will be requirements to deliver EPDs, environmental product declarations, that it stands for. Just in Sweden, next year in January, they're already there. They need the project manager, the owners, they need to deliver these. So it is of importance to understand what will come. And I will put this mildly, it's very important that we know what we are doing. Like you can see on the bullet points, building and constructions account for approximately 40% of the energy-related CO2 emissions. And there is an inefficiency of materials up to 50%. That's very common. So, this is something we need to do together. So how can we do this with the models that we provide? Or actually, how can we do this with constructible models together? Because there are several parts in the project. This is just to explain how you see a detailed model, how you see a constructible model. BIM level of development is called LOD. It's an industry standard that actually defines how the building models 3D geometry can achieve different levels of refinement. You can see it, I think I mentioned it before, like it's a measure of degree of maturity. So I think the next picture might give you a little bit more detail of what this is, but just one more explanation. I put it RFIs in the middle. That's request for information, and that means if you have models in early stage, you will have a bunch of questions because the models does not include all the information that you actually need. So to illustrate this on a very easy way or a smooth way, you have the conceptual model and you do have the construction model. And you can see the difference. You can see it illustrates benefits to use the stronger model if you call it with a LOD. And that's the difference if you compare the old traditional versus the constructible. And what do you get? You get all the plates and bolts. You get all the embeds. You get everything regarding pipes for MEP. You get the reinforcement, the rebars, everything inside of the model you will see, and it will be exact. You do go for the bolts, and of course you have the layout points for the building site. So this is the difference. And it's very important for you guys to know, if you're studying architecture, you do the conceptual design, but to use, I mean, the engineers, they will use your models, and you have the possible function to do the design, and then they take over, and then they do with the constructible model. And this is what they need to do to kind of add up with the information inside of the model. To help with that, we need client requirements. And this is a built project in Stockholm. It's an interchange called Vega. And in this project, it was Trafikverket in Sweden, they order it, and the Swedish Transportation Administration. And they had very high digitalization requirement. And it's so precise that the customer requirement that must change because the model increase the quality. So that means we need high quality of models because we need them exact, because that will be important. And the richness of detail will create the constructability, and it will enable you to use it fully in the sustainability work. This project generated both environmental and work environmental benefits, partly through the complete quantity removal list that was actually taken from the model. And it was able to reduce the waste significantly, and partly because it has been easier to plan the whole set in advance, which actually reduced a lot of stress and fire extinguishing. And this project, this is the ELU and Skanska project in Sweden. Further on, I'm talking about constructible for sustainability. And I mentioned before, so accurate you can build with it. So that's the key to constructible models. And of course, it generates sustainability. Many people today complain that the quality of the models they are receiving is not what they want. They can't use the information is not correct. The model is not what they expected. I mean, sometimes somebody else take a decision for me, but I see that this won't work. So the type of information model you want to have will be for you to point out in the future. It will be the project's kind of the paraply to gather all the information in the project. And to be able to participate, to be able to use the model for assembly, for call-offs, for financial management, or I mean, why not just of course, to use it for all the upcoming climate declaration. It will be very important that we do have this constructability so we know what's inside the building. So what do you need to be able to optimize your building to reduce the climate footprint? The workflow for designers and construction is based on an information flow between the constructible models and the collaboration between everyone involved in the project, from architects to the plumbers to all the people. Working with an open API will be for the best collaboration that will be necessary as the digitalization means that we actually communicate and collaborate. It is the people who will make the difference. Tekla Structures provide tools for realizing projects around the world today, from home and bridges and factories and skyscrapers as climbing halls. And it's the good communication that will eliminate the waste. And the waste makes the industry more with less waste, it makes the industry more sustainable and of course cost effective. Constructible models are used to create, combine, and distribute highly detailed, constructive and information-rich models of any material to support construction process that needs in design or manufacturing or construction site and the management afterwards. So, how do we go with that? How can we use these models to reduce the carbon footprint? I mean, the impact of the construction will be examined more and more. And since buildings and facilities account for more than 40% of energy related, we must do something. Sustainability over time requires exact amount of material to get really sound CO2 reduction strategies for all projects. I mean, to start at early age, you can really optimize the building. As you can see on the screen, it's up to 80% if you do it early in the design. But of course, you can also further on in the project, you will increase the maturity of the model. And over time, you will have this higher load. But in order then to be able to use all the data inside of the objects and to create, for example, climate declarations or product declarations, depending on where you are in the industry or who will use the data. We need to take advantage of this. We need to take away tasks that takes a lot of time. I've talked today a lot of the constructability of constructible models from the sustainability perspective. And I mean, what do I mean? How can I help? I hope that I have kind of brought up some new thoughts, because it's throughout the visualization and access to the information of the model that we actually can create these understanding of the design. And we can also reduce errors. We can, during the whole process, we can make this building or bridge, we can do that sustainable. And that is exactly what we will do. And you will listen after this one on Sarah when she go over with the one-click LCA and how you can use these models. But if you use a Tekla model to make these objects traceable, you have all the materials in there of the construction, no matter, everything is included. And the constructible model reduces waste. I already said that. It's resulting in a smaller rubbish heap or a rubbish pile. And you can optimize the material to use this. And it means that you actually reduce or even eliminate the amount of waste, because you know exactly what's inside of your construction. And that's really beneficial. So what have I learned from this? What can I what can the constructible BIM model do for you? I mean, of course, it can automate LCA calculations with a BIM integration. The life cycle assessment calculations can be performed from an early conceptual stage to a finished building where all the advantage to use the constructible model is accurate, and you will have the high LOD that gives clearer and more accurate results to your calculations. The constructible models in open format, then you're modeling your data that will be useful today as well in the future for coming up generations. You can track, you can quantify, you can optimize the materials acquired and actually used in the project. And you can reduce and eliminate the waste totally. To start in the design to think about, I want you to, in early stage, already think about recycling, rebuilding, but also disassembly, adaptation, and circularity. Those four are as well very important for the future together with the models. And you can and will, through that, secure for the future. So I said this earlier, that these two are equals, that the use of constructible model makes object traceable, all materials, no matter what. It is, and they are included. You need to increase knowledge and increase awareness of the information contained in the models. You need to use the information in final stages of a building, and that will tell you exactly what the building contains. We need to collaborate, architects with design engineers and the people on site. And for them, using a high LOD model, that means that they will know the exact location, the exact number of, for example, rebars, and they will know that they can open this model later on because we have saved it and collaborated it through an open format like IFC. So we do not have any choice. We need to do something that benefits the sustainable process together during the entire building life cycle. So this will be my last picture. So with the model-based workflow, you need to see the benefits. You need to know what a constructible model is. You need to know that it goes from conceptual design, early design, to detailed mature models, and that you need to use them in production, but also later on in the cycle of a life cycle of a building. So thank you for listening.
Thank you very much to Lindblad. Yes, there are many takeaways from your presentation. To me, this idea of open formats, open data formats, and understanding these models as platforms for collaboration across design and management, I think that's quite important point. Thank you very much. I propose that we move straight to Sara Tikka and One-Click LCA, and then we can have a discussion at the end. So we move to the interesting topic of counting the carbon emissions. Thank you very much. And Sara, please, floor is yours.
Thank you, Panu. And thank you, Tuve. A really good presentation. Hopefully, well, let's see, I'll open my camera so you can actually see who is talking to you. So yeah, if you weren't here present in the beginning, my name is Sara Tikka, and I work for One-Click LCA, which is a, well, software company. And I'm here to talk about calculating the carbon footprint, starting basically where Tuve left and continuing from there. So if I start, first of all, on making my PowerPoint work, perfect. So if I start, first of all, from who we are, the company name is One Click LCA, used to be Bionova, so same company, different name. We are a Finnish company that works today globally around, I would say, a bit more than 100 countries. I guess 130 was the correct number, but somewhere along the lines anyways. And today we are the world's leading construction LCA software platform. So not just talking about one part, but the whole LCA, the whole life cycle of a building. We start from materials, we continue with the operational phase, and then think about the end of life and, well, any other impact we have in construction sector. We, of course, do also other tools, not just for building LCA. We have tools for product manufacturing. We have tools for site designing, anything you might need in the construction sector. And the main point is, now you should be able to see it.
Yes, we can now.
Perfect. All right. So yes, we work with different certification schemes. Every time we think about LCA, quite a lot of countries do that based on different certification, based on different standards, based on different calculation methodologies. We do work with the whole industry, at least try to. So we engage with engineers, architects, manufacturers, builders, investor institutions. That's why we do have different kind of tools, because of course, different parties need different kind of tools. They need different, they need different advice, and they need different information on how to carry their work and how to decarbonize whatever it is that they are doing. Well, then, if we go to the actual meat of today, which is life cycle analysis and carbon footprints and how to calculate all of that, we will start with a short introduction to life cycle perspective, because it's a really important thing to consider it whenever you are doing any calculations. So what we talk about a life cycle perspective, not just, for example, manufacturing of materials, or just, for example, energy, or just the end of life of any material, is because, well, of course, we do have a chunk of emissions that come from other places as well. If we look at trends from, maybe the past 20 years and the future as well, we have an oncurring trend of urbanization, which means that our cities will grow. We need to build more, and we need to build more buildings where people can live. We need to build more infrastructure. We need to renovate what we already have so that they are in a premium living condition, which of course means a lot of consumption of construction materials. So it has been estimated that by 2060, we would be creating approximately 230 gigatons of embodied carbon just from construction materials. And that is also why, even though I'm talking about a life cycle perspective, I am mainly today considering and concentrating on embodied carbon, meaning the carbon coming from building materials during their life cycle. I would say approximately 1/3 of this comes from new construction, if we look at the emission amounts, and then 1/3 from infra, and then the rest from renovations, demolition, and so on. And if we look at where we are trying to go, of course, we are trying to achieve net zero. That's the whole topic of today, right? But we need to also think about it in terms of how much we will decrease our emissions in the construction sector alone. Of course, each sector needs to decrease their emissions, but World Green Building Council has estimated that all construction should create at least 40% less embodied carbon by 2030. And of course, taking a bit more ambitious approach with operational energy emissions. Well, as we have already heard today from the first talk about energy emissions, about decarbonizing our energy grid, about achieving projects with net zero energy, the further we go, the more we think about those things, the more the relative importance of embodied carbon actually comes forward. And this is really important for all of the participants. I mean, of course, some companies have bigger scope 1 and scope 2, meaning energy and fuel emissions, but usually companies have quite big scope 3 emissions, which means then the embodied carbon one. So we're talking about materials, for example. And if you look at, for example, designers and how they can impact these emissions, how they can impact the emissions from coming from new construction, what they can most impact is usually the design. So that means that they have a huge leverage over how much we emit from our building materials, how much our design emits, and so on. So each of us do have some sort of impact to that, hopefully at least. Well, why do we do this and why do we need to calculate? Of course, we have a huge demand these days that is driven by governments, that is driven by markets. We, of course, do need to calculate our emissions, but we shouldn't always think about it as something that we need to do. We should think about it as something that we have the possibility to do. And the more we gain data, the more we gain knowledge, the more we calculate, of course, the easier it is to understand what we're doing. And when we understand actually where our carbon emissions come from, what we're doing, and where we're going, it's always easier to actually act on that. Then if we go to the main thing today, which is embodied carbon accounting, and how do we actually account for our emissions? Mainly I'm today, of course, again, as said, talking about embodied carbon, but also the whole life cycle, meaning also the operational carbon emissions. Well, whenever we think about our carbon footprint, it's of course a result of something. It's usually a result of ready-made LCA, life cycle assessment. The life cycle assessment itself, it tries to ensure that we get a holistic picture of the performance of the building or of the product, or I don't know, anything we're calculating. You can calculate your breakfast as well. So LCA is just a methodology to try to find out the emissions over the life cycle of whatever you're calculating. The point in LCA is that it tries to help you avoid sub-optimization. Everybody has probably heard about greenwashing, knows what greenwashing is, has seen greenwashing. So the point of LCA is to bring us knowledge in a way that you cannot cheat. Well, of course you can always cheat, but preference would be that you wouldn't. So you actually need to take into account how much greenhouse gases or how much greenhouse gas emissions your material manufacturing creates, how much greenhouse gases your construction creates, how much greenhouse gases your use phase creates, meaning also not only operational energy emissions, but also renovations, refurbishments, maintenance, and so on. And then how much greenhouse gases you get from the end of life of your building or product, meaning the demolition and then processing of whatever it is that you're processing. And well, the end result of this is then the kilograms of tons of carbon dioxide equivalent, meaning then the we usually talk about the carbon footprint. Usually we can, of course, measure other things as well, such as euros, the energy emitted, and so on. We do have different scopes of carbon accounting though. So even though the point is to avoid sub-optimization, we can choose a certain scope that we want to look at. First of all, we can look at the embodied carbon part, meaning the upfront carbon coming from those materials that we purchase, those materials that we choose. Then the use stage embodied carbon, meaning, for example, all the replacements coming in from your materials that you're using. Then we look at the end of life carbon of those materials, and then the beyond life cycle ones, which usually means, for example, their reusability or their recyclability, and the benefits that come from that. Then we have the whole life carbon, which of course means everything that was in embodied carbon, plus then the operational carbon, meaning at this point, the operational energy emissions. All the calculations that we do are always based on standards and certifications, and all the rating systems or all the national methodologies, they usually approve either ISO or EN-based standards, or at the best case scenario, they do approve both. So first of all, we have usually the ISO standards. Then, for example, in Europe, we use the EN standards that are based on the ISO standards. And then on national level, we might use some national methodologies, such as in Finland, the Finnish Environmental Ministry one, that is then based on the EN standards and on the ISO standards. But the important thing here is to remember that whenever you do any carbon accounting or carbon calculations, use some sort of a methodology or standard, because it ensures that your projects are calculated the same way than if your neighbor chose the same one. And they're actually, well, usually maybe not verified if we talk about building LCA, but they ensure comparability. And because we need a lot of data to be able to bring the development forward, if you don't do it according to the standards, if you don't do it according to registered methodologies, you then, well, the data you've acquired might not be that useful, or maybe it is to you, but not to anybody else then. Well, then if we look into more detail in life cycle stages and what we talk about whenever we talk about carbon footprint, or whenever we talk about LCA, we have different scopes, we have different life cycle stages, but the main aim is that we would actually measure everything. Of course, national methodologies usually bring a bit of easiness into the doing part. First of all, we have the product stage, meaning all the raw material supply all the raw materials we're using, then the transport to manufacturing facility and the manufacturing part. And this is something where, for example, the models that Duru was talking about, where they come into the picture. This is usually something you get from well-built models. So, well, that of course reduces manual labor, but also makes it easier to understand what it is that your building takes inside and what you need to calculate. Then we have the construction phase. We of course need to get emissions for transportation to the construction site. We need to consider the installation of these materials and how much energy our construction site uses, and so on. Then we have the U stage, which is the B stage, where we have everything that happens during the building's life cycle. Usually it's calculated for 50 years, for 60 years, but we need to account for everything that happens there. If we have, for example, some, leakages, some maintenance issues, we should be able to account for them. Of course, those are usually things that you cannot know before the building, and thus quite a lot of national methodologies actually exclude them from the scope. Then we have replacements, for example, which is really important to include. Why? Even more so if we think about net zero, we need to be able to select materials that last longer. The more we need to replace materials, the more emissions usually. Of course, not the truth every time, but usually. Then we have, of course, operational energy usage there that we should always take into consideration when we talk about building LCA. At the end there, we have end of life, meaning the deconstruction, transport, waste processing, and disposal of every product that we had inside the building. Usually, whenever we talk about carbon footprint, we usually always talk about the carbon handprint as well. And the carbon handprint is then there in yellow. The D module, the benefits and loans beyond the system boundary, And there we usually account for example, if we have any energy that we sell out of the building, if we then it considers also carbonization of certain concrete structures, for example. It can consider the reusability of the materials that we're using after their life cycle, and so on. Then, if we think about optimizing for embodied carbon, well, that is certainly something we must do if we try to aim for net zero. And well, hopefully we will try to aim for net zero. So if we look at optimization, and even more so optimizing for embodied carbon, it really pays off to think about these things throughout the whole process. From the start of the project, we can look at soil, for example, how different soil types do affect our emissions. Usually we might need heavier foundations, we might need stabilization for certain kind of soils, meaning that they actually increase our emissions quite a lot. Then, of course, the further down the line we go to concept stage, to design stage, we can start to actually model our building, try to find the best possible options in our design, try to find the best possible options to reduce our emissions. And the further down the line we go, even more so. Of course, it's not that easy to get any big changes done anymore at that point, even more so if we are at the as-built stage, or well, even at use stage. You cannot really change anything anymore, or not at least anything huge, but it's still good to see how you did, and well, did you go at least at all where you were supposed to? And if we think about, well, keep on thinking about the earlier stages, is good to be doing something at least. It's usually always cheaper as well. The earlier in the project you start thinking about your carbon emissions, the cheaper it is to make any certain decisions. And if you look at then the operational phase of the building, well, you might be able to do something, but well, it's quite costly at that point. Well, if we look at optimization and what should we do, well, the most obvious saying anybody has ever said to me is only build for a need, and that is totally true. If you don't need a building, don't build it. Of course, after need, transformability is always good. Energy efficiency is important. Even though we are decarbonizing our energy grid by quite a lot, we still do have emissions coming from energy. So quite a good place to find the places to optimize. After this, when we move to architecture, when we move to structure, we can try to optimize the amount of materials we use, preferably use less, even, well, at least at that point when we don't need. We have a pretty bad habit of over-engineering, so could be a good idea to get rid of that habit. And yeah, after that, of course, we can look at the maintenance, how the building operates, how much emissions the operational phase needs. Always do adapt the LCA approach you are using in terms of where you're going in the project. The more details you have, of course, please do include those to your model. Makes it easier to optimize, makes it easier to understand where all of that data comes from, where you will get the information, how to do and what to do. And then after, of course, choose the right methodology and scope. There are a lot of methodologies you can do calculations with, and there are a lot of methodologies used in the market. Depending on the country where you are, you might use a different one. Depending if you're aiming for the certification, such as BREEAM or LEED, you might use a different one. Or, well, mainly, usually it's dependent on the geography or geography side of things. Well, after you've actually done all that, chosen whatever you're doing, do test, compare your carbon optimization strategies, see where you started, build a baseline, and go from there. Well, if you look at a good project, it's always nice if you have more than one design, because at least it then tells you that you have been doing something. So here we have, for example, a project where we had the starting line there, or the starting point here on the left. And then the further down the process we were going, first passive energy, seeing how much that actually reduced our emissions, then seeing, okay, if we reuse the foundations, how much better is that? Okay, if we build with a wooden frame, how much better is that? And so on. So that is the way how you can at least try to find the optimal point. But always, of course, in real life, the money also is quite important. So it's always good to remember to measure the costs at the same time. Well, then how do we get to net zero? Well, I think we all would be there if we would know a brilliant way to do that. Of course, we are going quite far with that. And even more so, as said, we are going quite far with that in energy side. But if we truly want to go net zero, we need to be able to do that with materials as well. So how do we do that? Well, if our energy emissions are in line, if we're done everything we can there, we can try to reduce carbon by using less virgin materials. Trying to use reused materials is always good. Recycled materials, always good. Usually they reduce emissions by quite a lot, depending, of course, on the building part and on how much you use in that. Then, of course, the less you use fossil energy, always good, and the less you have replacements during the life cycle of the building. The point is that to truly achieve net zero, we need to get our emissions to be, smaller than the removals / replacements that we have. If we then think about the right side of this picture, so the restore climate part, we can, try to sequester biogenic carbon if we can. Of course, today we talk quite a lot about different kind of carbon sequestering options. We talk about carbon offsets, and in the future we will see how good we are doing on that front. But hopefully the future will show us at least. Then if we think about this in the point of view of standards, the reducing carbon versus restoring climate, usually the reduced carbon we do on the carbon footprint part, and the restore climate we do in the carbon handprint part, if we say this in a quite vague manner. All right, that was actually all my time today. Mostly I would say that I actually went a bit over the limit, at least in terms of timing. But if you have any questions, I'm happy to answer them. And yeah.
Thank you, Sara. A lot of detail on these different elements of calculating. I think in the beginning you said that if you look about 2 generations to the future, 2060, you estimated that urban construction would cause 230 gigatons of carbon. And then you said that with, let's say, this type of tools we are discussing now, we might be able to reduce 40% of that. There's still 60% left. Yeah. Could you put that a bit in scale? I mean, how much is that amount of gigatons concerning the climate targets, for example, this famous 1.5 degree target?
Well, if we look at that 230 and then the 40%, the 40% mainly talks about new construction only, the one that World GBC has put forward. It's mainly a target so that we can ensure that the construction sector is going to the right way. Of course, that target is from World GBC to 2030. It means that, of course, we are reducing by a considerable amount of carbon, but of course it also means that we have a considerable amount left, even more so if we keep on building as we are doing, and most probably we will keep on building.
Yes. Yeah, it's big topic, and I think Nicholas provided very hopeful view to them to the energy during the use of buildings, and I think we all agree that it is it's not easy, but it is a bit easier part of the equation, and then this embedded energy is quite tough, obviously. Maybe, I mean, I don't see questions now from audience, but there's a lot of discussion about wood, and also you mentioned in one of the examples moving from for example, concrete or steel to wood frame. Based on different experience, how would you estimate the impact of that one change, moving to wood? How important it is roughly?
Well, it can be really important, and if it's done right, even more so. I actually have here one example where I have three different kind of buildings. So we have concrete, steel, and timber. And then if we look at the emissions coming from there, if we compare, for example, the concrete building and the timber building, it's almost 100,000 kilos of CO2e less if we build from timber. Of course, this always depends on the building, if we need to add some other materials because we're using timber, or if it adds to replacements, for example. But usually, of course, timber is a bit better. But of course, you can build from concrete in a good way as well, I guess, by reducing the amount of concrete you use in total, by using concrete that has recycled binders in cement, for example. That would help. So it's really dependent on the design and on the products you use.
Yes, I think it's definitely healthy reminder that first of all, do you need a building, then choosing the right site to the building, and then the basic design solutions are very, very important. And then
Yes.
The more technical fine-tuning is also important, but as you said, possibilities to influence grow smaller during the process. That's clear. It's interesting examples, so there is quite significant change. Ian Brooks, please.
Thank you, Panu. Sarah, thank you. A really interesting presentation, a great tool.
Thank you.
Clearly, EPDs are really important in terms of
Yes.
making this practical. How good do you find the quality of EPDs currently, and particularly being able to choose between manufacturers who make the same product but may have a lower carbon footprint themselves?
Yeah, I mean, great question. EPDs are crucial in terms of being able to measure building materials and their emissions. The quality, I would hope, is good, at least. Into some terms, I'm a bit hesitant to say about any certain manufacturers, anything like that. But if we look at EPDs, it's really important that we keep the notion in there that they are third-party verified. That's why I at least do trust the data, because I know that they're not just some random numbers that have come from somewhere. And well, while there is issues, while we don't yet have enough knowledge, we don't have enough EPDs to be able to compare every single manufacturer in the planet. But if we look at it in a European context, we do have enough so that we can seek for information if we want so.
And can you say what is EPD?
Oh, yes, sorry. So Environmental Product Declaration is a declaration of the product's carbon emissions and its performance, well, environmental performance. So the point of an EPD is to bring you knowledge on the raw materials used and of their emissions and of the emissions of the manufacturing process, so that you are able to then measure all the building materials that your building uses.
Yes.
Great.
Good.
Thank you very much, Sarah.
Thanks.
Yes, it's interesting. Yeah, I wanted to raise this wood because we are soon moving from this building level to urban level and to whole land use issues through Kati's presentation. I think there is rather a big issue coming with them. Simply the amount of wood we are using. It is a question if there is high demand for wood for not only for construction, for many other uses if we want to replace fossils. So what is then the ecological impact of use of wood?
Yeah,
there is now one
definitely.
question from Sila Kartai, and did I Kati, did you raise hand as well?
No, but I commented.
Yeah, I
you
was
commented,
actually
yes. For some
actually
reason,
reading.
I don't
Yes.
see the chat right now. Now I see this.
Yeah, definitely. And it's always important that everybody who is doing, well, anything, not only buildings, considers the usage of sustainable forest cutting as much as possible. So no, of course there are always problems, and even more so in certain countries or certain regions. But yeah, usually
Yeah.
that's not something that is reflected wholly, like entirely in an LCA. But of course, if I look at today's standards in terms of life cycle analysis and of these environmental product declarations, the new standards bring a bit more information on the usage of biogenic carbon, because the benefits you get in the beginning from using timber, of course, the same carbon is released when the timber is incinerated. So that's also something that today we are able to see from EPDs, at least in new ones.
Yes. Yes. Yeah, Kati's comment is very much to the point. Sila, you had a question.
Yeah, I had a question. Actually, when we talk about the LEED certificate, it reminds me Istanbul Airport. If you know that, it's the largest LEED certificate building in the world, but the airport was not built in its place in the strategic plan, and during the construction process, almost 30 million trees were cut down, and because it was built on the migration route of birds, both some species were displaced, and it's not easy to fly for the planes, but at the end it has a LEED certificate, a golden LEED certificate, and it makes me think about the trusting those certificates is a good thing or not.
Yeah, I mean, it's a great question, and I'm not familiar with the case itself, but if we ever look at any certification, it's not, well, if we look at any calculation, never trust anything before you actually read it. And that goes for any scientific paper as well. I mean, it's always good if you get the knowledge behind it. There are problems, like said, in LCA methodologies. It doesn't account for everything. For example, if we demolish an entire forest just to be able to build one house, I mean, nobody wants to see that be done. And that's something that we cannot really reflect in an LCA. I would just hope that then people doing the zoning part of the job would consider the climate impact of that. And yeah, but it's a really important point. Yes.
Yeah, thank you.
True. Great. Thank you very much, Sara, Tikka, Tuve Lindblad, Nicholas Salomaa. Let's have a short break, and then yeah, we have about 5 minutes. We can take coffee or something else to keep us going, and then we are actually good in time. So sharp 6 o'clock, we move to Kati Vierekko's presentation. Short break. Welcome, Kati. We got big amount of rather technical type of views. I mean, what's your feeling about seeing all that, what the building industry is doing. There is a lot of work, but I think we got a sense that there is still a long way to go to achieve a fully zero carbon society. Yes, I think we can move to Kati Vierikko's presentation, and there is at the end hopefully time to a little bit wrap up. So if you have time enough to stay still until 6:50, let's have a concluding discussion at the end. But please, Kati, floor is yours. Kati is coming from Syke, from Suomen Ympäristökeskus. I always forget the English name. State Environmental Research Institute. Is that the?
You will see it soon. It's like
right
this.
English. Good. Please, floor is yours.
Okay, thank you, Panu. And yes, what I will tell you a bit is based on my previous research and what I have learned during being active, also nature conservationist in cities, and taking part of participating for land use planning processes. So here I introduced you the idea how we could cycle, taking the circular economy ideas and bring it to supporting biodiversity in cities. A little bit my own background. I'm actually a biologist, and I defended on sustainable forest management, and then I did postdoc research 4 years in different projects looking at especially socio-cultural and socio-ecological values of urban nature and how to enhance biodiversity together with citizens in cities. And when I started to work in Syke a couple of years ago, my first challenging task was to go through how current land use planning in Finland supports circular economy, and that's the report published last year. Okay, what we mean when we speak about the biodiversity, it has been a huge topic nowadays. Even Helsingin Sanomat has own biodiversity toimittaja today, and as you have probably seen. But usually when we speak about biodiversity, we very much kind of narrowly think about the number of species, but it's much more, and it's a connection from very genetic level processes from landscape, their patterns, but also looking at the functionality, how different processes worked, what kind of benefits we speak about ecosystem services they provide for human and our society. All these are combined and are parts or components of biodiversity. When we speak, as I said, it has been quite clearly also argued at the global and European level that we need to change our directions towards sustainability transformation for biodiversity. And this has been highlighted also in many new European Commission policies like a Green Deal and a new strategy for biodiversity. So I will go through giving some examples how we can support biological cycle and biodiversity in cities, having 4 principles from circular economy concept reduce, reuse, recycle, recover. But here I would like to bring fifth about reconnect, and especially how to reconnect people with biodiversity. Okay, previous talk we already discussed about that construction is causing huge carbon emissions, and it's also occupies a lot of new land, still urban sprawling, despite it has been a bit decreased, for example, in Finland lately, but it's still a huge problem, also recognized by European Commission. And therefore, already at the beginning of 21st century, the European Commission took an idea of that we should avoid to occupying new rich soil, and also the idea of circular land use were brought, the clever use of land. European Commission set up a zero net land take goal 2011, but actually this was in one strategy paper, but this was not really brought in a higher level in European Commission. But I think this is still very good goal. We all should aim in cities when we consider growing cities especially. And why we need this kind of clever way of using soil is that the soil is the one we need to have a diverse and functional nature in cities. And I will more tell about what kind of benefits soil produce here, just giving few examples. That especially very rich virgin topsoil provides better ecosystem functions, and also the higher diversity in vegetation. It increases also the microbial biodiversity, and by using different kind of vegetation can also improve the functionality of the soil, and having evergreen and deciduous trees together, for example, in parks, improve the carbon and nitrogen sequestration in public parks. Another thing also which is nowadays also happening quite broadly in Finland, in growing cities, that due to climate policy and other reasons, the city structures has become very compact, and especially these kind of more these suburbs with having a huge private gardens are nowadays demolished and infilled, and this infillment project usually then threats the existing vegetation. Having example this from Mellunmäki, and these old, not so old houses, maybe 50 years, not even 60 years, will be demolished, and all these large trees will disappear in this area. And when we use the land reuse, Kalasatama is a good example of how we should kind of efficiently use the land that has been already previously occupied, instead of sprawling the housing into natural areas. We have also good examples in Finland that not necessarily when we occupied former brownfields or harbor areas, we can, instead of having the housing area, we can transfer them back to be a green areas, as is Sea Park, Meripuisto in Kotka. And also in Kalasatama, we have studied that in one project, Smarter Green Cities, and already based on our our analysis, the amount of green cover has increased due to greening structure brought to that area. Of course, excluding Mustikkamaa island here in the picture, but looking at the construction site of Kalasatama. Then the third principle is recycling. If you can't reuse or reduce, recycling is a key principle in circular economy thinking. And I go through with 3 examples how we should recycle soil mass, organic matter, and different biodiversity components. As it was said that the pre-construction phase can be at least quite high in carbon emissions, and also the developing grey infrastructure are still consuming huge amount of virgin natural resources in Finland, and through that also the construction waste is most of that is also coming from surplus soil. And actually this has been quite heavily reacted in Finland, and many cities, especially growing big cities, have had they systems to recycle the surplus soil. And City of Helsinki, I think, is a good example of this, that how much they have had positive environmental impacts by efficiently recycling surplus soil in different construction sites. In Porvoo, there's an example that the city used the degraded material from the river by developing a new park. Of course, the soil has been kind of it has been common way for a long time that it has been dumped to green spaces, that at least it has been used somewhere. But this was kind of a only case that the degraded material from river was used for park construction, and this place was also considered to be biologically rich park. Kuninkaantammi in northern part of Helsinki is a pilot area testing especially how to use the recycling the soil, rock and other materials locally, not bringing from other areas, and they have very much used this also in green structure development. Although have to be critical here that as was mentioned, that this Kuninkaantammi is partly built to forest area, so it doesn't fill the two principles of circular economy. And then lately, maybe you have also followed news how much the diverse nature have a psychological improves psychological well-being, but also physical well-being, and especially if we bring this rich topsoil from forest, we call it in Finnish kunta. For example, in a kindergarten yard, it can significantly improve the resistance of small children towards flu and other diseases. And this even the City of Helsinki has developed a model how to remove the topsoil in construction sites and reuse or recycle it somewhere else. And as I said, there's been studies lately in Finland that has found scientific evidence why it's good to have hands on soil, so to speak, that bringing especially for children having contact with the rich topsoil and rich diverse environment is good for them. And then about the recycling organic matter, in actually green spaces in cities are usually quite intensively managed, not necessarily in terms of supporting the sustainability and also increasing carbon emissions. But what City of Helsinki has started to do, they have now a piloting how they could more efficiently and largely collect the green organic matter from green spaces and recycle it, and even have some kind of business model for that, because some of those waste at this point are burned and not composted. So it's in that sense it's not necessarily the best way of managing or handling them. And when we speak about the recycling, we could also recycle local genetic gene pools in terms if there's a construction site in Tampere Hiedanranta, there's an example that the biologist collected seed from the soil and especially went them through, and the aim is that they reuse and recycle these in the development Hiedanranta area, and so maintain the local diversity of vegetation and supporting especially rare native species. And of course, then we can recycle components of biodiversity. Dead wood, important for many insects and fungi. Many pollinators need these places, so we can easily bring these particles of biodiversity into the parks. And on right hand side you can see this kind of dead wood fence, lahopuaita. And not so much studied and not so much known that how much actually the green structure industry the uses recycled material, because some of them can be also using virgin natural materials and not necessarily recycled ones. This is example on Kuninkaantammi that they also in developing green spaces, the aim was to use as much as possible locally recycled material. And another thing is also, which is very common in Finland, that our seabeds, which are used in green space construction, is peat-based, but now I think there will be a new materials available without peat on seabeds. And then, of course, we had to bring the nature back to cities. In Finland, we are in rather good positions, but more compact cities in Europe is really aiming also to develop new types of green spaces, areas, or restore or degrade habitats. A new strategy for biodiversity 2030 is aiming also that bigger cities or cities having more than 20,000 inhabitants, they should develop ambitious urban greening plan, aiming to increase amount but also quality of green spaces in terms of supporting biodiversity. And when we recover nature, it can be done in different ways. This is restoration project of wetland in northern part of Keskuspuisto Helsinki, or we can bring small parts of meadows into parks, supporting pollinators and other insects and species. This is my favorite place in Töölönlahti. This is one example how we can bring more diverse management methods to also very central areas in Helsinki. And then Green Roof, this is in in Syke. And so we wanted to have a green roof in our bike saver, or how you call this. So we had that established last year. And finally, I shortly would like to bring up the idea that we should also reconnect, especially urban citizens, with biodiversity. If we are too used to this kind of environment and nature, there are already studies revealing that we are losing our connection to biodiversity. And when the urban environment is more or less done by humans, we kind of forget to how the kind of wild nature looks like, how it smells like, how it feels. So it's important to have these connections. And it has been quite many studies showing that especially childhood direct connections to wild nature also enhances our understanding towards other species, acceptance towards nature, and also lately support this kind of a pro-environmental behavior. So this is my last slide, just to want to say that we really need to have these kind of wild nature patches in cities, that they give us idea how the nature itself functions without human control. Thank you.
Thank you very much. Yeah, it's a real program. Reduce, reuse, recycle, recover, reconnect. Very, very good and important points. There are many questions, and I would a bit like to link also to them earlier talks of today. But let's start from them. Also like planning a strategy type of question. You mentioned also this current trend of densifying cities, and especially in the growing areas, Helsinki, Tampere, a bit Turku. We all know densities go up. There is high rise is commonplace also in Finland nowadays. How would you balance? Because we heard that from this technical life cycle assessment and carbon calculation, it is not easy to get the whole urban effect. We are still actually quite far from understanding the carbon, not even mention biodiversity, but even carbon in them urban scale. So in this kind of strategy level, how would you comment this trend? Okay, it's of course good to densify. We get shorter distances. There is more use for public transport. Anni Sinnemäki is saying that Helsinki is good for low carbon lifestyles because there is a lot of public opportunities, public transport, public space, short distance. But at the same time, it means more complex construction. You need expensive structures. You need a complex solution for car parking and so forth. So, as compared to a lower density and simpler construction, when there would be then, for example, exactly green yards and so forth, more common. I think this very basic planning strategy question is a bit, I think, open still.
Are you asking me kind of commenting?
Yes, I'm asking, how would you comment?
I think of course there's a lot of studies, and maybe I give more of my own opinion. I just want to be sure I'm not representing Syke at this my comment. But I know that there's a kind of studies that densifying city structure at certain points, kind of positive effects are achieved, and after that not necessary anymore. As you say, already the construction phase are causing so huge carbon emissions peak that actually, as was estimated previously, that whether we never achieve these with very positive thinking that now people are starting to use public transportation and so forth, but still we have many people want to have their private cars, and so and studies from Aalto University has shown that the city lifestyle is much more consumption oriented than in a smaller cities or towns. So the overall, the individual carbon emission is not necessarily lower. So I don't think if the overall goal of reducing carbon emissions, are we really achieving this with very much just the focus into densification? Because I think I personally myself, if of course people want to move certain areas, but still I would see that most efficient would be small scale town network on a broader scale, so that they are very nicely connected, and but that this is more my personal opinion, and I don't know if there's study, for example, city of Oulu or city of Lappeenranta, city of Kouvola. I think those are very nice. City of Kotka is very nice size of cities. You are easily accessible everywhere. Already Helsinki, despite it's not mega city, it takes me from Töölö to Viki almost 40 minutes by bus and walking, and I think it's much. So we lose those when the city structure becomes broader, and so it takes so much time and effort to move one place to another. So what I would see if we could keep Finland alive, that we would have a network of small scale cities, still compact, still having, but not too compact, having all services. People are wanted to live there, but problem of course is more societal and others, that we unfortunately have many shrinking cities in Finland, and this is also interesting discuss, because nobody wants to admit that they are shrinking, and they are kind of fighting against that phenomenon. But we have considered that there is kind of this smartly shrinking cities concept that I don't remember, but yes, the idea that you accept that you are shrinking and you do it in a smart way, not like trying to, but yeah, of course it's another question, but maybe now long answer.
If you're in this, everything needs to change. We are discussing well, systemic change. It may be overused word, but it's in a way clear that the very ambitious targets they cannot be achieved only by fine-tuning the way we are doing things at the moment. We need some quite big changes, and I think what you said about bringing biodiversity to them top of the agenda, it has a bit that promise that many things are rethought. This idea of net zero land use for urban functions, it's quite interesting, and I started immediately to think that, of course, in growing cities, it means using industrial and transport lands for urban construction, which of course is commonplace, and it's quite well understood. But still, there is more green spaces taken for urban use. Just now, as we know, there is quite hot political debate about Vartiosaari, about some other places where maybe policy actually is now changed. So at least for the time being, Helsinki stopped.
Vartiosaari, yes.
Helsinki stopped some greenfield projects, which is great. But I was thinking that if you look on the scale of a whole country, of course, the best would be to continue using what is built, as you said, in other places, in small towns. But our economy and our society is not pushing in that direction. It's pushing in the opposite direction of making the biggest Helsinki especially to grow very much, and then exactly some places losing. Of course, in some sense, you can then regain green in theory in those shrinking cities, but that's a bit maybe small issue. It's maybe not solving the whole, but it's quite complex. I mean, Saratikka from OneClick, I think she said very clearly, built only for real need, and that's of course it's easy to agree, but at the moment quite much of construction is also for making money. It's not only for real needs, and I think there is quite a big question opening there. Yeah, this dimension of understanding biodiversity in its full spectrum, I think that's very good. So it's really not only about the amount of species, but it's about the landscape morphology. It's about the biome, the bacteria, and also then the connection to humans. So there are quite direct benefits from biodiversity to human health, for example, mental health and physical health. You had this one slide on biological cycles and technical cycles. Maybe that's something to comment, because it's often, I think, forgotten that in the end we should see cities as part of nature in a way. I mean, that might be one element in this systemic rethinking, that we don't see that cities are some kind of artifacts put out of nature, but in the end it's one system, one global system. Yes, I don't see questions from audience. Any questions, any comments to Kati or to other speakers? I guess there has been pretty long, as sometimes happens.
People get tired. Yeah, you never know even if audience is there, because nobody has.
Exactly. Sometimes
disappeared.
sometimes the audience disappears. Yes. Yes. Somebody is saying that we are still here. Good. I think we got quite
somebody raised a
quite
hand.
interesting set of points of view. The idea of today was to start from let's say the current best practices of industry, and as said, I think we got 3 very interesting lectures on what building industry and the information linked to different phases of construction, what can be done, and it was partly very promising, partly still questions open, but yes, Sampa, please.
Hi, and I just wanted to keep the conversation up about this. What is the future model for cities or urban habitat? So Kati had a vision of this smaller scale villages or towns linked, and I think this is something this kind of idea has been in architecture and urban planning present for quite a while, coming from probably from garden city ideas already over 100 years ago. So, and there probably are some very nice places to live, which are kind of like that. But do you, Kati, have any ideas what it takes to like to this kind of lifestyle to be more, or like what's the word?
Attractive.
Attractive,
Yeah.
for like young folks that are nowadays they are moving to cities to study, and there's more work available in big cities and more culture and whatever possibilities to consume in different ways. So how we need some kind of like, if this is part of the solution, this web of smaller towns. So what's the, it needs some kind of cultural change also, I guess.
Yeah, good point. And in my dream, town would be at least that big that there should be a theater and cafes and all city services, city life. So not necessarily like a garden city type, although there would be enough public parks, not necessarily private cars, but public parks to share. So yeah, this garden city was, which basically were brought to Finland as a forest city, or we had a Metsälähiöt, which kind of present is a Finnish type of idea of garden city, I think. But yeah, and of course, young people especially want to leave to become big cities. So some kind of it needs shift in thinking and respecting living in a smaller cities which don't necessarily have so much services and other to offer. So I don't know.
Yeah, some other, maybe it was an ACAN discussion, but with this idea of more self-sufficient culture, but that we would grow more of our own food nearby and produce more of our energy locally, could be one idea how to tackle climate change and net zero, carbon zero future. And I feel like your idea of the web of smaller places connected, it could be like one part of this vision. But yeah, we need to make it more sexy, like solution. No, what's the like? Sorry, I'm losing the English, but not solution, but counter to study and the affection it has to young people at the moment. What could keep people in the smaller places? And this is kind of hard problem, I think. Yeah.
Yes. Yes, it's big question. We are at the moment working with Jyväskylä, with the city center of Jyväskylä, and of course in Finland, Jyväskylä is one of the big cities, but even there, it's not easy to sustain the livability, the services, of the center, you need some quite specific new actions to almost like reinvent them, the smaller cities. So that's I think there is something in those elements. Kati brought wild nature, reconnecting to as important part of the rethinking of maybe exactly small, medium-sized cities. But clearly there's still work to be done. There is. I saw Tuve Lindblad still. Are you still on online? Great.
Yes,
I had one question. I mean, to a little bit link these two sets of talks today. You discussed very empathetically about BIM models. Do you see some scale issues? Like, I mean, clearly building it already becomes complex, but it can be done. It can be very, very detailed. And you had this example of one large infrastructural project, a huge crossing. But based on your experience, is there some kind of meaningful limit to the scale of a model? Could a whole neighborhood, for example, could you do this kind of model with meaningful accuracy at the moment?
I would say that you would have a different model for different buildings, not
Clearly.
in one. No, but that would be used in, I would say, other products to kind of, and tools to show a whole city. But for the accuracy and this exact detailed HiLOD model, I mean, you have one for each building, but the building can be huge. So that doesn't matter from our side. But I know there is, I mean, like I said in the presentation, we need to do this together. We need to collaborate. We need to see that it works with different formats. So we need to communicate with open formats. And right now, maybe that is a little bit, I mean, all the software providers need to kind of work together to get this get this going. But this highly detailed model, I would say no for now, regarding to put the whole city or a whole neighborhood in the same model.
Exactly, yeah, because there's a lot of talk about digital twins, and also in the urban scale and even in national scale. But
I would not. I mean, you can have digital. Yeah. You can have the twin of your project.
Yes.
But I would say the digital twin of a city, that's another software.
Yes.
I think our dogs thinks that it's time to go out.
I have some biodiversity next to me. Yes.
Yeah.
Yes. He's still young, but already quite big. Also, Sampa is having a dog. Good. Yes. In chat, there is some discussion about the multiple and confronting targets of sustainability, but I feel that we can start closing the discussion. Thank you very much, Tuve.
Yes.
Greetings to Stockholm, Helsingør, to Stockholm.
Yeah.
Thank you, Nicholas and Sarah. Thank you, Kati, and good questions from audience. We had again interested and well-informed points of view from people. The recording will be put in the eikan.fi website. Raul is just sharing the link, and we continue next week with questions of bottom-up processes and how to keep people with, how to co-create new solutions with citizens and users of spaces. So we go more to the social dimension.
And these events are open for all. So
yes, these are open. So there is this Eventbrite. So when you go to the eikan.fi website, you you get them links most easiest. There is one thing I just now make it public because it has been a long time in my head, and now Kati, you mentioned this sustainable forestry practices. Would you like to join, and if you would make maybe the next ACAN event on exactly the use of forest, because I think it's such a big topic and in a way quite open question in especially
Yes, it is.
in the Nordic countries, Finland, Sweden, also Norway, Russia. I think there is great potential to help in our goal if we would start a serious discussion about the use of forests, and then linking also to the construction sector as we discussed in the beginning of today's set. I was just having good discussion last week with Sebastian Veldhuisen, who is promoting sustainable architecture. They have a very interesting office in The Hague in Netherlands, and he was building a parking house out of wood. And then I was asking, okay, from where the wood is coming? Well, from Finland. So there we are. I mean, great. But then there is a small question with that. Good.
Yeah, very important topic. I see if
everybody. Let's
join.
keep in touch. Let's keep in touch, and let's make maybe after Christmas a next ACAN round from cities to forests.